And that's the energy?
This is the energy that's going from the water into the metal. Yeah. If you guys don't like looking at these Q's and M's, you can also call it this, guys. This is the energy out, and this is the energy in. If we know that energy is going from the water into the metal, okay? Energy in equals the energy out. Again, these numbers still have to be the same as each other. Anybody got our QW?
Yeah, 1,148.
Was it again, Max?
1,148.
Okay. And so that's in joules. So that also means then that our QM is also the same number. Okay. If you guys remember learning in algebra how you can set equations equal to each other when you have the same unknown on both sides of the equation? You guys remember doing that, guys? Your math teacher didn't tell you this, but you were taught that so you could do stuff like this. I know that may not seem that radical or that amazing, but all the point of all this time you spend in the 400 building is so that you can actually use the math to understand stuff here. I don't think they do it very well. I don't think the way we teach math and science in this country is very good at all. But that's what it's supposed to be. When you learn how to handle algebra, it's supposed to help you with this. I mean, it would have been a whole lot better if you could have learned how to do that in algebra while you learned how to do this same stuff here. And you actually see that there's a reason why you have to do it. That's my soapbox 2 cents. Okay, so now we have the Q of the metal. We know that this is going to be equal to 24.0 grams times 50.4 times C. Now this should also be an equation that's pretty easy for everybody to solve. Take the 81.48 and you divide it by 24 times 50.4. And then you're going to get C all by itself. Okay. I know it seems like a lot of steps, guys. It's like putting two of these Q equations together to one problem. Like I said, it's the end point.
Once you get to that, what does it get it in both calories per gram?
That's easy. I'll show you how to do that. What did you get, Noah?
6.73.
Okay, 6.73, and that's joules per gram degree Celsius. If you want to get into calories, all you got to do is divide this by 4.185. 1 calorie equals 4.185. Okay. Those of you guys that are doing this with us, did you get the same thing that Noah just shouted out?
You lost me when you said 18. Pretty much.
Go ahead and jump that out as well.
It's going on for YouTube.
Anybody else get something different? You just get lost at 18. Everybody else gets 6.73. But I know, guys, you feel like you can do it now, and you're pretty uneasy because we walked you through it. But there's other questions on here that are going to ask you the same thing. Any question that involves putting something hot inside a calorimeter is going to be solved like this. The energy out of the hot stuff equals the energy going into the cold stuff. Always has to work out like that. Okay. Anybody else still writing this down?
We're good.
How are those QW and QM, how are they the same?
Okay. Good question, Master. I want to make sure everybody leaves today with a good understanding of that. This is hotter than this, right? And we know that heat flows when there's a difference in temperature. So long as this metal that was dropped in this water is cooler than the water, energy is going to flow into the metal. Okay, you good with that? It's going to stop when the temperatures are the same. Okay, and all the energy that left the water is the same energy that went in the metal. They always equal. Energy in equals energy out. Before fall break, we told you guys about the conservation of energy. So it's always got to be conserved. And it's conserved when we have things that are different temperatures because that's how we interpret how energy works. That's all we can do. You can't see a calorie. You can't see it. All you can see is the result of something hotter transferring energy to something colder. All we can see is that if I burn something like wood or I burn something like in an explosion, I can see that it releases heat in the process. So it's hot and then you're detecting it with something cooler, so it's absorbing the heat. But that's kind of how we understand it. Okay, good? All right. I want to look at 19 and then the motor oil question too. There's a question on the back that talks about a sample of motor oil. Okay. 19 is kind of like what we have up here with this graph going on. It's going to be asking you guys how much heat it's going to take to turn 550 grams of ice at negative 15 degrees Celsius to 10 degrees Celsius.
So it's 25 degree temperatures, right?
It is.
So
But in that 25 degrees, guys, is it just going to do this? If I make a graph,